We're going to go ahead and start out by talking about arithmetic sequences and series in this lesson. If you just have a list of numbers like you see below, that's referred to as a sequence. Now, each number in the sequence is called a term. So 2 would be your first term, 45 would be your second term, 345 would be your third term, and so on. Now, a sequence in which the difference between any two numbers in a row is the same is referred to as an arithmetic sequence. That difference between those two terms we refer to as the common difference. So an example of that is what you see over here on the right. If you're at 5 and add 4, you get 9. If you're at 9 and add 4, you get 13. So if you keep adding 4, 4 is referred to as our common difference, and you keep adding 4 to be able to get the rest of the terms, and this is referred to as a arithmetic sequence. Now, some sequences may be infinite, meaning they go on forever, while others may only go for a set number of terms, and that's referred to as finite. Now, the arithmetic sequence formula is as follows, where we're dealing with this formula. When we are looking at A1 right here is referred to as your first term. D is referred to as your common difference. And then N is the term that you're looking at. Now, if you're writing in general the arithmetic formula for a sequence, you're going to leave N out of it. But if you're looking for a particular, or not out of it, but leave it as N. If you are going to go ahead and find a particular term, like if you wanted the 12th term, then N would be 12. Now, let's take a look at these next few problems here. We're looking at the next three terms of this sequence. Well, you need to go ahead and figure out what is it you're adding each time. Now, you might be able to see that, but one way to be able to figure that out is always to take one term, I'm going to take my second term, and then subtract the previous term. And in this case, you would get 7. So that lets you know you're adding 7 each time. You could even do the fourth term minus the third term. As long as you're subtracting one term minus the previous term, that helps you find your difference. It doesn't really make a difference how you do it. So we know we're adding 7 each time. So if we're at negative 10 and add 7, we're at minus 3. If we're at minus 3 and add 7, we're at 4. If we're at 7 or if we're at 4 and add 7, we're at 11. That is how you can find the next few terms. Now, there's a couple ways we could do this one, but the easiest way to be able to list the first 5 terms, well, first of all, you're given the first term, and then you're told you're adding 5. So you could just keep adding 5 to this term, and if we add 5, we get negative 13. Add 5 again, you get negative 8. Add 5 again, you get negative 3. Add 5 again, and you would get 2. We're supposed to list the first 5 terms, and we did. Now, could you go ahead and find your formula? Yes. Now, down below, we could do the exact same thing here, but notice we have to go out to the 20th term. You may not want to do that. So we could use this formula over here on the right. So I'm going to go ahead and plug in my first term, which I know is 29. I'm going to go ahead and plug in N, which I know is 20 because that's right here. And I know my difference right here. So I'm going to go ahead and look for my 20th term. Plug in my first term, which is 29. Then I'm going to plug in 20 for N because I'm looking for the 20th term, and then plug in negative 30 for my D. Now, I don't want to put negative 30 like this because here it looks like subtract 30, but we need to be multiplying by that, so we put parentheses around it. So now I can go ahead and take the right-hand side of the equal sign and type it into my calculator, and I get negative 541. That's one way to do it. The other way is to just Start at 29 and keep adding a negative 30 each time and do that for 29 times. I chose to use the formula here. Whichever way you do it doesn't make a difference. A lot of things in this chapter can be done in multiple ways. When it's talking about an explicit formula, it wants you to use this formula right here, but it wants an n left in it. So all we have to do is plug in our first term. Well, we know that here, and that's your first term. And then plug in your difference. Now remember, to find your difference, you can always go one term minus the previous term. You either go the second term minus the first term, or you could even go the third term minus the second term. Either way, you get negative 10. So I'm going to put negative 10, but remember to put it in parentheses. When you're asked to find the explicit formula, you could actually just leave it like this if you want. If you wanted to go ahead and distribute through the negative 10 into your parentheses, and I see I forgot a 1 here for this, you could, but you wouldn't have to. Next, let's talk about arithmetic means. So with arithmetic means, you might be given two numbers like 8 and 898. Arithmetic means are basically where we got to figure out what two numbers go in here so that it ends up being an arithmetic sequence. So we're going to go ahead and use this formula right here. Now, we don't know what we're adding each time. So that's our difference. We are going to use this being our last term, so I'm going to put that here. Now, as you know, this is your first term, your second term, your third term, your fourth term. So 98 is your fourth term. So I'm going to put in 4 for n because that's your position or the term you're dealing with. We also know that we are having a first term of 8. So I'm going to put that in for my first term. So now I'm going to go ahead and solve this. We have 98 is equal to an 8 plus a 3d. Subtract 8 from both sides. And then divide by 3, and I get 30. So that means I'm adding 30 each time. So if I'm adding 30 each time, all I have to do is go 8 and add 30, and I get 38. That's a funny looking 8. There we go. Add 30 again, and I get 68. Now, if we add 30 again, we should get that last term of 98, which we do. So your arithmetic means are what we put in our blank spots there in red. Now, if we come along and instead of listing our terms with commas in between, if we added our terms, meaning we put plus signs in between, then we are dealing with a series. Arithmetic series means you're still adding the same number each time to go from one term to the next term, but a series means you have addition signs in between your numbers instead of commas in between. Now, we have two formulas that we could use. Most of the time you'll use this first formula, where that's still your first term. This is typically the last term of your sequence, and then this is the number of terms. In the formula down below, you still are going to have the number of terms. You're still going to have your first term, but you don't know your last term. But if you don't know your last term, you would typically know the number of terms you're looking at, which is, once again, n. And you would know your difference. So let's go ahead and use our formulas to help us find the sum of these series. Now, as you look down below here, we need to use the formula that has first term, difference, and n. There's no d in our first formula, but there is a d in the second formula. So I'm going to use our second formula. I'm going to go s sub n 2 times my first term plus n minus 1 times my difference. And I'm going to go ahead and plug in n in both spots. Then I'm going to go ahead and plug in my first term, which I have right here. And then I'm going to go ahead and plug in my difference into that formula. Now I can just type it into my calculator just as I see it. And when I type that in, I get 200 or 2,620. Looking at problem 57 over here, I need to go ahead and use the formula that still has n, but I need to use the one that has an a sub n, and that's our first formula. So if I write that out, I need to plug in my first term, which is 5, plug in my last term, which is at 25, plug in the number of terms, which is n, and now I can just type that into my calculator. So just as I see it, I could type it in, and I get 165. On this next problem, you'll notice we don't know our last term. So we do know n, and we need to know n for either one. We also know our first term, and we need to know that for either one. We could either choose to figure out our last term, or we could choose to use the bottom formula. But the bottom formula, you need to know your difference. Well, we can easily go ahead and go our second term minus our first term, or third term minus our second term to find our difference. And you'll notice when you figure that out, you get your difference to be 7. So if we plug stuff into that second formula, plug in our difference of 7. We also have our number of terms being 7. And we have our first term being 24. And then we could go ahead and type it in just as we see it. And in this case, we get 315. Now, notice on this problem, we know that we're dealing with a series, even if we didn't read the directions, because you notice we have plus signs in between our numbers rather than commas. If there were commas, we'd be dealing with a sequence. Now, when we're looking down below here, we're going to be looking at what's referred to as summation notation or sigma notation. It's really another way to be able to write a series. For the most part, what we're looking at here, this bottom number is the first number you plug in. And you plug it into your rule here, 10 times 1 minus 5 is 5. Now, this funny looking e thing here means you're adding these terms. Well, we're only plugging in nice normal numbers, so the next number up from 1 is 2. Plug in 2, and you notice you get 15. And then you go ahead and go plus, and you plug in your next number up from 2, which would be 3. Plug in 3, and you get 25. And then you keep doing that until you plug in this top number. Well, if you plug in that top number, to be able to work this out, you end up getting 295. I always recommend when you're dealing with summation notation to basically write out your series in a way like this. That way it allows you to be able to find your first term, your last term, and what you're adding each time, which is your difference. Now, n is the number of terms. It's pretty easy to figure out n for the number of terms because you're starting at 1 and going till you get to 30 for your inputs here. And so that means n is ending up being 30. So I'm going to go ahead and use my first formula over there, n being 30. I just find it easier than the second one if I have a choice, but either one would work. My first term, which is 5, my last term, which is that 295, and then all I have to do is just type that into my calculator just as I see it. And when I do that, I get 400 or 4,500. So looking at this problem, we're trying to find n. We have s sub n, we have a sub n, and we have your first term. If you look at the four things I highlighted, you want to choose the formula that deals with those four things. And in this case, it happens to be our first formula. So all we're going to do is basically write down that formula and plug things in. Now we have s sub n, which goes over here on the left side. We have our last term. We have our first term. And then we're trying to find n. So to be able to work this out, what I'm going to choose to do is go ahead and work out what's in the parentheses. And when I do that, I end up getting a 34. I'm going to go ahead and choose to take my 34 and divide it by the 2. Well, when I do that, I end up getting 17 times my n. So to solve it for n, I divide both sides by 17, and you'll notice when you type that into your calculator, you get 15. Now, pause the video to read through this. I always recommend starting out by basically trying to write out what you're dealing with. You have having a fine of 3,000 for the first day, and then each day it goes up by $1,000. We're trying to figure out when we're going to be at $25,000. Now, there's a couple ways you can do this. You could go ahead and use this bottom formula, but you don't know n, and that's what it is you're looking for, the number of days. And you can use that, plugging everything in, and solve it for n. It ends up being a little bit more challenging because you're dealing with a quadratic equation then. I would say just start adding these together. So the sum of the first three would be 12,000. Now, if we would add in the next day, which would be 6,000 right here, take that 12,000 and add 6,000, so the sum of the first four would be 18,000. And then I would just try adding in the next day, then that would be adding another 7,000. Well, 7,000 for the sum of the first five terms onto your 18 would be a 25,000. And that's what it is we're looking for. So our answer would be 5 days. So if you add the first five terms together, you end up getting your 25,000.